Okay, so it says, what is the standard form equation of the ellipse that has vertices at -2, -8, and -2, 2, and foci at -2, -7, and -2, 1? I think the easiest way to do this problem is just to graph it, and then you can see what's going on. The book shows other ways. They don't actually graph it, but I think my way is easier, but maybe just because these are integers. So, okay, but I'll show you what's going on. So we have vertices at -2, -8. So we know there's a vertex down here. Yeah, I have it all on there. And so -2, -8, I graphed that. -2, oh, no I didn't. I graphed +2, -8. Okay, -2, -8, let's get the right point. Right there. And then -2, 2. Okay, so -2, 2. Those are the vertices. Okay. The foci are at -2, -7. So there's 1. And -2, 1. Okay. We know then that this ellipse is going something like, not like that, but something along those lines. We know that it's got the major axis. We know how long that major axis is. We can figure out what the center is, right? So what's the distance between here and here? 10, right? So between -8 and -2, you could just count that out. And it's got to be halfway in between the center. So 1, 2, 3, 4, 5. That's going to be my center. I can double check it. I'll put it in black. I can double check it by counting 1, 2, 3, 4, 5. Yep, it's in the center. So whatever that point is, that is my center. Now I can figure out from the graph, because these are integers, the center is -2, which we kind of knew that. It had to be in line with the foci and the vertices, and then it's -3. Okay, so I know h and I know k. All right, the goal is to get x minus h squared over b squared plus y minus k squared over a squared equals 1. And now we know what h and k are, okay, just from the graph. We also know this distance right here. We just figured that out a minute ago, that was 5. So we know a is 5. A is 5. That means a squared is 25. Okay. We also know c. This distance for c is 4. You could just count that off the graph. So I know c is 4, and that c squared is 16. Now, it doesn't matter if you go above the center or below. You can just count that off on the graph. And then I'm going to be able to find b, because c squared is equal to a squared minus b squared. So my c squared is 16, my a squared is 25. So I can figure out my b squared. So if I subtract 25, I get -9 equals -b squared, or 9 equals b squared. So b is actually 3. I'll scroll. B is actually 3. 3 is B. So if I wanted to do this more accurately, it should have gone 1, 2, 3. There's a I had one of those, right? And 1, 2, the other co-vertice is there. So the graph really should have looked more like this. Not so much football shape, but mine's kind of footballish. Okay, now do I know h, k, a squared, and b squared? I do. So I can write x. It's going to be minus -2. I'll have to fix that in a minute. And then y minus -3. And then my b squared was 9. That came from right there. And my a squared, we knew that, was 25. So I'm just going to write it one more time so it looks nice. X plus 2 squared over 9 plus y plus 3 squared over 25 equals 1. That is going to be the equation for this ellipse in standard form. One thing I'm going to point out, that addition sign is very important. That's what makes it an ellipse. Okay, now as we do other conic sections, you'll see that, but I just want to point it out now. This is an addition sign. Okay,